Hi friends, inequalities, exciting stuff. X greater than 7. X less than or equal to 3. X greater than or equal to -2. All of these can be described graphically as well. So if we're looking at these inequalities, we can take a look at their central focus, which is 7 in this case, 3 in this case, and -2 in this case. And as long as we read these inequalities properly, meaning read from the variable, we'll be able to understand what these statements are actually saying. So the first is saying x, start with the variable, x is greater than 7. I'm looking at 7, but I'm just talking about the x's that are bigger than 7. So I'm looking at all the x's that would be to the right of 7, where the bigger numbers live. In the second example, we're looking at the x's, or the numbers, that are less than or equal to 3. Well, here's 3. You want 3, so we'll shade it all the way in. And you want the numbers that are less than 3 as well. And that's the numbers to the left. Left, what? Okay, x, in the final example, x is greater than, or the numbers, any number can go here, so it's a number of numbers, the numbers that are bigger than or equal to -2. Well, here's -2. You want to be equal to -2, or you want the x's that are bigger than. Bigger than or greater is to the right. Feeling good? Do you know how to solve this complicated equation? I hope so. I hope you can combine like terms, bang, bang, and do what you need to do to solve. So let's combine like terms first. That provides this statement, and then we tell the story about our variable, in this case x, is being subtracted by 2, so you would do the same thing on both sides, the opposite of what was just said. X is being subtracted by 2, so you would add 2 on both sides, resulting in the answer of 14. Not a big deal. Let's travel further. My claim is that nothing changes when this here equation changes to this here inequality. You solve these things the same exact way. So let's do what we would do if this here were an equal sign. Let's just pretend it is for now. So let's do what we need to do. Let's simplify both sides first by combining like terms since we have them. Here's a -2 on the left with x, and you still have x minus 2 is less than or equal to 12. Let's keep playing the game. Let's try to get x by itself. So here we would add 2 to both sides, and we're seeing that x is less than or equal to 14. So this inequality is solved because we know that for this inequality above, right up here, the only thing that will make it true is when x is less than or equal to 14. And you can express those solutions graphically by showing a number line, looking at 14, and saying that here's 14, x must be equal to 14, so we'll shade it all the way in, or it can actually be less than 14, less than left as well. Any number you choose to the left of 14 will satisfy this equation up here. Let's even make it simpler so we can hammer home this point. In order to solve this inequality, what we're going to do is treat this as an equal sign. We're going to play pretend, treat it as an equal sign, and solve as if you would a regular equation. So here, the only thing left to do is tell the story and undo it. So you're subtracting 3 from both sides, and you're going to look at x is greater than 1. That's it. You're done. X, or the numbers, any number that's bigger than 1 will satisfy the above inequality. This is your solution. Here's your solution graphically. Look at the number you're interested in, this 1, and we want the x's, read from your variable, the x's that are bigger than 1. Well, here's 1. You're not interested in 1 exactly, but you're interested in the stuff that's bigger. The stuff that's bigger is out here to the right. So any number that's bigger than 1 will work as a solution for this above inequality. Let's try it out. What's bigger than 1? How about 2? If you put in a 2 here for x, 2 plus 3 is 5. And of course, 5 is bigger than 4. So that works out. In fact, any number that's to the right of 1 will work and make this inequality a true statement. Okay, friends, when you solve inequalities, just like you're solving equations, you're going to have the variable by itself on one side and the number part on the other side. Remember, with inequalities, it's very, 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 very important to read from the variable. This will help you graph the solutions more easily. Here we have the numbers m, or any number that's bigger than 4 works. Well, here's 4. We want the stuff that's bigger than. This seems pretty easy for most of us. Let's keep going. M, or the numbers that are less than 4. Okay? Here's 4. We want the stuff that's less left, right? Another one, the numbers that are greater than or equal to 4. Here's 4. We want 4, so shade it all the way in. We want the numbers that are bigger than or equal to. Bigger than would be out this way. Now be very careful with this next one. I'm trying to trick you. You want to read from the variable. So starting over here, read this. The numbers m that are less than. Read this part first. The numbers m that are less than or equal to. Well, here's 4. The numbers that are less than or equal to 4, less than left. So you'd be shading out this way. Yeah, that's as complicated as it gets, folks. For this idea here with solving inequalities, treat it just like an equal sign, so I won't even write it anymore. I'm just going to treat it like it is. I'm going to combine like terms on each side. Easy steezy. Here we are. A lot of these numbers look the same, I've noticed. You're going to try to get the variable by itself by telling the story. M is being subtracted by 2, so add 2. It seems like we just did a problem like this. 16 is less than or equal to m. Now be careful, I read that incorrectly. Let's read from the variable in order to graph this thing properly. Take a look at what you're interested in, 16, so I've graphed that on my number line. And now I'm going to read from the variable. The numbers that are bigger than, here it is, bigger than or equal to 16. Well, here's 16. You want bigger and you want equal to. We're done. But just to check yourself, you can go back up to the top and plug in a number that's bigger than 16. How about 17? And see if that works for this equation. Or inequality, rather. 17 with 3 is 20. 20 minus 5 is 15. Is 15 bigger than or equal to 14? Of course it is. So it looks like we've got the right solution down here, where we're looking at the numbers that are bigger than or equal to 16. Go ahead and try these delicious examples. Pause the video so that you can see all the problems, and then do them, and then be happy that you know how to do mathematics. Yay, math!